for a 120/208 volts, 3-phase, 75 amps machine with a 4-wire configuration and a distance of 40 feet from the panel. Number 4 American wire gauge copper wire is needed for the circuit conductors. For the equipment grounding conductor, a number 6 American wire gauge copper wire is needed. The choice of conductor size is primarily governed by ampacity, which is the current carrying capacity of a conductor without exceeding its temperature rating. Several factors influence the appropriate wire size, including the load current, conductor material, insulation type, ambient temperature, and the presence of other current-carrying conductors. The National Electrical Code, or NEC, provides tables that specify the allowable ampacities for various conductors under different conditions. When selecting wire size, it is critical to consult the appropriate NEC tables, such as Table 310.16, to ensure that the chosen conductor can safely handle the load current. The ampacity of a conductor is determined by several factors, including the conductor material, its size, and the insulation type. Copper conductors generally have higher ampacities than aluminum conductors of the same size. The insulation type also plays a significant role, as different insulation materials have different temperature ratings. Conductors with higher temperature ratings can operate at higher ampacities. For example, THHN insulation is commonly used for general wiring and has a higher temperature rating than some other insulation types. In this specific scenario, the machine operates at 120/208 volts, 3-phase, and draws 75 amps. The distance from the panel is 40 feet, and the system uses a 4-wire configuration, which includes 3-phase conductors and a neutral conductor. The equipment grounding conductor provides a path for fault current to return to the source, minimizing the risk of electrical shock. The size of the equipment grounding conductor is determined based on the size of the overcurrent protective device protecting the circuit. The NEC specifies the minimum size of the equipment grounding conductor in Table 250.122. According to this table, for a 75 amps overcurrent protective device, a number 6 American wire gauge copper wire is required for the equipment grounding conductor. The 75 amps load is a significant factor, meaning the conductors must be able to safely carry this current continuously. The 40-foot distance can influence the wire size due to voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, the following formula can be used. Voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor in ohms per foot, divided by 1000. The impedance of the conductor depends on the conductor material, size, and temperature. Larger conductors have lower impedance, resulting in lower voltage drop. In this case, the distance is 40 feet, which is relatively short. Therefore, voltage drop is unlikely to be a major concern, assuming the conductors are properly sized for the load current. The NEC specifies the requirements for conductor ampacity in Article 310. The ampacity of a conductor must be at least equal to the non-continuous load plus 125% of the continuous load. A continuous load is a load that operates for 3 hours or more at a time. If the 75 amps load is continuous, the conductor ampacity must be at least 75 amps plus 125% of 75 amps, which equals 93.75 amps. Therefore, a number 4 American wire gauge copper wire with an ampacity of 85 amps at 75 degrees Celsius is not sufficient for a continuous load of 75 amps. A larger conductor, such as a number 3 American wire gauge copper wire with an ampacity of 100 amps at 75 degrees Celsius, would be required. However, if the 75 amps load is non-continuous, the number 4 American wire gauge copper wire would be sufficient. In addition to ampacity and voltage drop, it is also important to consider the termination temperature rating of the equipment. The termination temperature rating is the maximum temperature at which the conductor can be terminated at the equipment. The NEC requires that the conductor be sized based on the lowest temperature rating of any connected termination, conductor, or device. For example, if the breaker is rated for 75 degrees Celsius, the conductor must be sized based on the 75 degrees Celsius ampacity rating. The conductor must also be suitable for the environment in which it is installed. If the conductor is installed in a wet location, it must be listed for use in wet locations. If the conductor is exposed to direct sunlight, it must be sunlight resistant. The type of insulation used on the conductor is indicated by a series of letters such as THHN, THWN, or XHHW. Each letter has a specific meaning. T stands for thermoplastic insulation. H stands for heat-resistant insulation. HH stands for high heat-resistant insulation. W stands for suitable for wet locations. N stands for nylon jacket. X stands for cross-linked polyethylene insulation. The THHN wire is a popular choice for general wiring applications. It has a thermoplastic insulation with a nylon jacket and is heat resistant up to 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. The THHN wire is suitable for use in both dry and wet locations. The breaker terminals are designed to accept a specific range of wire sizes. It is important to ensure that the selected wire gauge will fit into the breaker terminals. Most breakers have terminals that are designed to accept a range of wire sizes. The wire size range is typically marked on the breaker. To determine whether the number 4 American wire gauge THHN wire will fit in the breaker terminals, it is necessary to consult the breaker's specifications. If the breaker is designed to accept number 4 American wire gauge wire, the wire will fit properly. If the breaker is not designed to accept number 4 American wire gauge wire, a different wire size or a different breaker will be required. When installing the wire in the breaker terminals, it is important to follow the manufacturer's instructions. The wire should be properly stripped and inserted into the terminal. The terminal screw should be tightened to the specified torque. Over-tightening the terminal screw can damage the wire or the breaker. Under-tightening the terminal screw can result in a loose connection, which can cause overheating and arcing. The final step is to double-check all connections and ensure that everything is properly installed. The panel cover should be securely fastened. The circuit should be tested to ensure that it is working properly. When selecting wire size, it is also important to consider future expansion. If there is a possibility that the load will increase in the future, it is advisable to select a larger wire size than is currently required. This will allow the circuit to handle the increased load without having to replace the wiring. It is also important to consider the deterring factors that may apply. Deterring factors are adjustments to the ampacity of a conductor that must be made under certain conditions. For example, if multiple conductors are bundled together, their ampacity must be derated. This is because the bundled conductors will generate more heat than conductors that are installed individually. The NEC provides tables that specify the deterring factors that must be applied under various conditions. The NEC also specifies the requirements for conductor identification. Conductors must be identified by color coding or other means. The purpose of conductor identification is to make it easier to identify the different conductors in a circuit. The NEC requires that the grounded conductor, also known as the neutral conductor, be identified by a white or grey color. The equipment grounding conductor must be identified by a green or bare color. The ungrounded conductors, also known as the hot conductors, can be any color other than white, grey, green, or bare. In a three-phase system, the ungrounded conductors are typically identified by the colors black, red, and blue. The NEC also specifies the requirements for cable installation. Cables must be supported and secured in accordance with the NEC. Cables must be protected from physical damage. Cables must not be installed in locations where they will be exposed to excessive heat, moisture, or corrosive substances. The NEC also specifies the requirements for conduit installation. Conduit must be installed in accordance with the NEC. Conduit must be properly supported and secured. Conduit must be protected from physical damage. Conduit must be installed in a way that prevents moisture from entering the conduit. When working with electricity, it is always important to take safety precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take the necessary precautions to protect yourself from injury. Understanding these factors and consulting the NEC will help ensure the safe and efficient operation of the 120/208 volts, 3-phase, 75 amps machine. Remember to prioritize safety and consult with a qualified electrician if you have any doubts or questions.